All right, this is going to be my final video on the review packet for your Chapter 8 factoring test, and I'm going to go through the back side of your packet in a little bit out of order, and I'm going to explain what I'm going to do first before I actually do it. So first I want to just kind of refresh your memory to the factor flow chart that we got at the very beginning of our unit. And I'm going to go through the problems in this order. So before I solve a problem, I will look for the GCF, but what I'm going to do is pick out all of my 2 terms. I'm going to solve those first. Then I'm going to do all of my 4 terms. I'll do those next. And then last, I'm going to pick my 3 terms because there's a bunch of ways to solve your 3-term factors. So instead, I'm going to work through the back side of your packet in a little bit out of order. Again, in the order of first, I'm going to look at 2 terms, then 4 terms. And I'm going to use this to kind of reference as I go. So if you notice I go out of order, that's why. So as I'm looking at the back side of the packet, I'm going to start to just identify which problems are only 2 terms, and I'm going to highlight those. So I'm going to do number 22, and then I will work through number 26 because that's 2 terms. Then I will work through number 27, and then I will do number 28. So I'm going to do those problems first. Now, these 4 problems that I have, this is how I'm going to start to solve them. So with 2 terms, those 4 that I have highlighted, I'm going to first start with the GCF. After I do a GCF, I'm going to look for 2 terms that are perfect squares, and there has to be a subtract sign in the middle. If this isn't going on, then all you can do is the GCF and nothing else. So I hope that's really clear for just the 2-term problems. So as I'm looking at number 22, the first thing I need to do is look for a GCF. Is there a number in common with 36 and 49? And the answer is no, there's not. There's no factors that 36 and 49 have in common. So instead what I'm going to do is factor with the difference of 2 perfect squares. So I'm going to take the square root of each of the 2 terms that I have. I'm going to write those down in my factors. One factor will get a plus sign and one will get a minus sign. The order of your plus and minus doesn't matter. So this one is going to factor into a 6x and a 6x and then a 7 and a 7. So a 6x with a 7, a 6x with a 7. One factor gets a plus, one gets a minus. And that's it for number 22. For number 26, I do notice that there is a GCF right away. So I'm going to divide out the GCF of 2. So first, I'm going to divide out that 2 from each of my terms. Now I'm left with x squared minus 4. I notice the 2 terms that I have left after I've taken out the GCF is a difference of squares. X squared is a square, 4 is a square, so I'm going to factor with the square roots. One factor gets a plus and one gets a minus. So x times x and a 2 times a 2. One factor will get a plus sign, one will get a minus sign. And again, the order of your plus and minus doesn't matter. So this is my answer for 26. This was my answer for 22. For number 27, I do notice that I have a GCF. Now, GCF you should always do first, so that's what I'm going to do. I'm going to divide both of these terms by a 9, and as I look at the letters, I want the letter with the smallest power, so I'm going to divide by x squared. If I divide each term by 9x squared, my GCF, what I will have left is 1x plus 11. Now, the 2 terms that I have left is not a difference of 2 squares. And this would mean I could factor further. But since this is not a square minus a square, there's nothing else I can do besides the GCF, so this is done. Now, 28. I notice that these do not have a GCF, the 2 terms, your x squared and 25. So I cannot start with a GCF on this problem. And then as I look at my 2 terms, the only way to factor would be if your 2 terms have a minus sign and that those 2 terms are perfect squares. Our problem does not have a minus sign. When you have a sum of 2 perfect squares, you cannot factor this. And that literally is your answer, cannot factor. I'm going to stop this video here with all the 2-term problems, and then if you want to look at the 3-term problems or 4-term problems, check out the next video.